All right, this video is a couple of reminders about linear equations. So linear equations, there's a few different types. We have slope-intercept form. That's the most common one. It's y equals mx plus b, where m is your slope and b is your y-intercept. Now, your slope can be negative or positive. It could be a fraction or a whole number. B can be negative or positive, fraction or a whole number. It doesn't matter. Now, what's true, always true for a y-intercept, is that x is equal to 0 at that point. Imagine this. Doesn't matter what your slope is. If x was equal to 0, anything times 0 is 0, and then y would equal your b. You see that? Also, we can plug in any value for x and find y. So once we have our slope and we have our b, we can plug in any value we want for x and find our y value. Our y at this point is known as our solution. So we have that version. We also have standard form. Standard form, which is ax plus by equals c. This doesn't really represent anything. That doesn't really represent anything. It's not our slope. It's not our y-intercept. What must be true, is a must be a positive whole number in our final answer, and b just has to be a whole number or an integer. It doesn't have to be positive. It doesn't have to be negative. C can be a fraction, a whole number, whatever it wants. We also have something called point slope form. And this is y minus y1 equals m times x minus x1. Now you may remember m. M is from up here. They both mean slope. The x1 and the y1 just represent the point. Every point will have an x value and a y value. So with this one, you'll have a slope that either you have to find or you will be given, and then a point that will always be given to you. Sometimes they'll just give you the x value or the y value, and you have to find the opposite one. Anytime you're trying to find a solution, that just means isolate that variable. Right? So if you're trying to find that x1 or that y1, that means just get rid of everything else. Okay, so a couple of things we need to practice. There's ways to find our slope. Our slope has a formula as well. So slope formula is going to be, this is something we talked about previously too. Our slope formula is going to be m is equal to y2 minus y1 over x2 minus x1. These things are just points. Once again, everything takes an x and a y. So this is anytime we have an x and a y value with 2 points. So x2 and y2. These could be on a table with your x and y values, where you have numbers all over the table, and you can just pick 2 of them, call one of them x1, y1. Remember, your x's are on the left side and your y's are on the right side, so call one of them 1 and the other one 2, 1 and 2, and just plug them in to the formula. x1 down below, y1 up top, x2 down below, and y2 up top. When you plug them in, you subtract them, and then you simplify them together. Right? You will also need to be able to read a graph. I hope you remember what we talked about, which was we have our y-axis always. It's up and down, our vertical axis, or our horizontal axis, which is left and right. That's our x. If you remember, this is called the origin. At that point, both values are 0, and anything that occurs on this line, x has a value of 0. Okay, that goes back to our y-intercept, right? If x were 0, our y-intercept would be that value. So everywhere along this line, x is 0. So anywhere that a line crosses becomes 0, comma, that point. So here, our y-intercept would be -3. So for this equation, we'd have y equals mx minus 3. Now this m can be found using our slope formula. If we have this point and we have another point, 3, 0, we can find those points. We make one of these x1, y1, it doesn't matter which one, and the other one x2, y2. If it makes sense for you to go left to right, this would be x1, y1, and this would be x2, y2. So we would say y2, which is 0, 0 minus y1, which is negative 3. Subtraction is always built in, so we're subtracting a negative over x2, which is this one up here, 3, minus x1, 0. So 0 minus negative 3, that just means plus. So we get 3 over 3 minus 0, which is 3. 3 over 3 is going to be equal to 1, so I know that my m, or my slope, is equal to 1. Now I have my equation. I have y equals 1x, or just x, minus 3. Okay, there's our equation in slope-intercept form. Y is isolated. Our m is actually 1, a positive 1, and our y-intercept is negative 3. Okay, as a reminder, we can also do system of equations with this. This is when we have two equations at the same time. You'll use all that information that we just talked about, but you will use it twice. And systems of equations just have two lines. We still have our y and our x-axis, but we're looking for this solution where those two intersect. Okay, it's when both are equal to each other. We can do that through elimination method or substitution method. If you recall, elimination method simply has you subtract one equation from another to isolate a variable. So for example, if we had 3x plus 5y equals 15 and x minus 3y equals negative 21. Just made up these numbers. We would have to change one of our coefficients to match up with the other one. We have to eliminate, meaning we're using these two equations against each other. So we're going to subtract or add, and then we have to change one of these equations because none of the coefficients match up with each other. We have 3 and 1. We have 5 and 3. So nothing can be done. So I'm going to multiply this bottom equation by 3 to change this coefficient into a 3. By doing so, I can subtract these and eliminate them. And that's what we're trying to do. But I have to do the rest of them as well. So this one becomes 3x, this one becomes negative 9y, and this becomes negative 60, negative 63. All right, so now let's subtract 5 minus negative 9. 5 minus negative 9, that becomes positive. So 14y is equal to 15 minus negative 63. 15 minus negative 63, so that becomes positive as well, or 78. Sorry, 78. 78. All right, now x is gone, and we need to find our y. So we isolate our y. We get y all by itself by dividing 14 on both sides. Now this is yucky without a calculator, but we can slowly simplify it by dividing by 2 each time. So 78 divided by 2, well, half of 70 is 35, and half of 8 is 4. So together that would give me 39. So if I divide that by 2, I'd get 39, and if I divide this one by 2, I would get 7. That's as simple as it can get because 7 cannot go into 39. Now this is a yucky problem, but I want to use yucky problems to show you an example so you're not afraid of those. Our y is now 39 over 7, so I'm going to substitute this whole thing in for y into one of our original equations. I'm going to choose this one because it's less math. That's the only reason. So I'm going to rewrite this equation and say x minus 3 times 39 over 7 is equal to negative 21. All right. So this is like multiplying fractions here. Negative 3 times positive 39 will give me, what is that? 27, and then 9. So 117. Negative 117. Yucky. All right. And that's going to be x minus that is going to be equal to negative 21. So I'm going to add this to both sides. Okay, so if I have negative 21 plus 117 over 17, I can't reduce that to my knowledge. So I'm going to multiply both the top and the bottom by 17 to get a common denominator. So I get 21 times 17, 7, 1, 4, and then 0, and then 21. Combine them, 7, 5, and 3. So 357. So x will then be equal to 357 over 17. All right. Now, to see if this is going to be simplifiable, 17 is prime, and I need to go ahead and see how many times I can get 17 to go into 357. So, let's see. Let's start multiplying this number by big numbers to get it up there. 17 times, let's see, 20. 4, 1, and then 3. 340. Ooh, if I multiply it by 3, or if it's 340, add 17 more to that, all factors of 17, I would end up with 357. Well, I lucked out here. So 357 is going to be divisible by 17 and get an equal answer of x equals positive 21. All right. All right, so we found our answer. We have it at x is equal to 21 and y is equal to 39 over 7. Yuck. All right, and there's your x value and your y value of this intersection point. Not to this picture, but to this equation. Okay, please use everything you see here to do the next few problems, and I'll text them to you. Have a good day.